Hello everyone, welcome to my channel C.S.E-Pathshala. We were studying about machine learning using Python 3, and in this tutorial we will study about Pareto and Zipf distribution. So let's start with Pareto distribution. A distribution following Pareto's law, that is 80-20 rule or 80-20 distribution, which means that 20% factors will cause 80% outcome, is said to be a Pareto distribution. Okay, so the Pareto principle states that, as we have already told in the above line, for many outcomes, roughly the 80% of the consequences of those outcomes or the result is because of 20% of the cause, that is the vital few. Okay, the other name of this principle is 80-20 rule and the law of vital few or the principle of factor sparsity. It also has two parameters. First one is A, that is a shape parameter, and next one is a size, that means the shape of the array which we will return. Okay, so let's consider a code and then we will understand what a Pareto distribution is. So let's consider it and implement it here. Okay, so import NumPy as NP. From NumPy import random x equal to random.pareto. Okay, so we are using Pareto function or method here with an argument as a equal to 2 and size as 2, 3. So a equal to 2, that means that we are using shape as a parameter, and the size of the array which we want to return. 2 means there will be 2 rows and 3 means 3 elements in each row, or we can say that it will be having 3 columns. Okay, and then we are printing it. So let's save this code and run this code. Alright, so here it is, the output of the Pareto's distribution. Now, if you want to visualize Pareto distribution, so let's consider one more code, okay, and implement it here. So import NumPy as NP. From NumPy import random, import matplotlib.pyplot as PLT, import cborn as SNS. So we have already discussed about all these modules or libraries in the previous tutorials. NumPy is used for arrays, matplotlib is for plotting, cborn is for distribution. Okay, and yes, sns.displot random.pareto a equal to 2. Again, here we are giving the same argument, that is the shape as 2, and the size here we are giving as 1000 values. Okay, and kd equal to false, that means we are making false the Gaussian parameter. Okay, and then we are plotting this graph. Okay, so let's save this code and run this code. Alright, so here is the graph for Pareto's distribution. Alright, now the next is Zipf distribution. If you talk about Zipf distribution, it is used to sample data which is based upon Zipf's law. And if you talk about Zipf's law, it is a collection. The nth common term is 1n times of the most common term used in a collection. Okay, that means, for example, the fifth common word in a natural language or any paragraph, or we are just writing a big text, something like that. So it will occur nearly 1/5 time as the most used word in that paragraph. Okay, so for example, there is a certain word which is most frequently used in that particular paragraph. So the next common word which is used to that frequent word will be, for example, the fifth common word, okay, which has been used in that particular paragraph with respect to the most frequently used word is equal to the 1/5 times of its usage. Okay, so it has two parameters again. A, that is stands for the distribution parameter, and the size, that stands for the shape of the array which we need to return. Okay, so now if you want to draw out a sample of this distribution with a distribution parameter of 2 and size 2 cross 3, so let's consider a code and implement it here on Jupyter Notebook. Alright, so import NumPy as NP. From NumPy import random x equal to random.zip a equal to 2 and size 2, 3. So again, it has two parameters here. We are using Zipf method, and here we are using distribution parameter. A is equal to 2, and we are going to print an 2D array of size 2 rows and 3 columns. Okay, with 3 values each in every column or in every two rows. Okay, so we will print here by printx. So let's save this code and run this code. So here it is. These are the respective distribution for Zipf. Alright, now if you want to visualize this distribution, then consider one more code. Here we have been given a sample of 100 points, but plotting only ones whose value is less than 10. So we need to plot only those values who are less than 10 for more meaningful chart which we want to present here. So let's consider a code and then we will see. Okay. So here it is. Import NumPy as NP, from NumPy import random, import matplotlib.pyplot as PLT, import C1 as SNS. Now we are calculating the value for the or the random values for the Zipf distribution. That means x equal to random dot zipf a equal to 2. Okay, again we have taken the distribution as parameter as 2 and size we are taking here as for the 1000 values. Now, whatever the values which will be coming will be all stored in X. Then we are plotting the distribution for this particular value X, that is SNS.displot X. Now, here we are giving a condition here like that for those values who are less than 10 and Gaussian is also false. Okay, so here we are giving a straightforward condition as it has been asked for in a problem, that we need to clearly show your distribution. That means for a meaningful chart. Okay, so we are giving here a condition for x less than 10, print those values of x only. Here we are plotting it. Obviously on distribution plot we are just plotting it. Okay, so let's save this code and run this code. Alright, so here it is. This is the Zipf distribution. So that's all for this tutorial. We will come up with more exciting tutorials. Thanks for watching and kindly do subscribe to my channel.